Hello everyone. Right, let's just quickly do the second part of our trig revision, grade 11 trig revision. Okay, and I forgot to do something in the last session on reduction formula. It says expressed as a function of theta. It's just with, when you've got a square, so sine squared 180 plus theta, okay, you think of that as being sine 180 plus theta all squared. Okay, so that square over there means a square on the whole thing. So what that means is that if I reduce this, it would become, well, 180 plus, remember, where are you in that quadrant? What happens to sine there? It becomes negative. So it's negative sine theta all squared, and when you square a negative, it becomes positive sine squared theta. And you can go straight from there to there, because if you recognize that there's a square, okay, and it's a 180, it's not going to be a name change, okay, you're going to always end up with something like that. Okay, so just watch out for that. Alrighty. Okay, now we're just going to revise special angles from grade 11. Okay, and so the kind of question says, it will say evaluate without a calculator. And the things we can work out, the ratios without a calculator, are anything on the axes, any angle on the axes, so 0, 90, 180, 270, 360. Okay, and then our special angles 34, 45, and 60. In my opinion, it's a little bit of a dumb section now because your calculators can give you nice cert answers as they couldn't in the past. But in MBTs, you may come across them, and in some varsity courses, and in your exams, and then you've kind of got to at least know how to get everything to a special angle. Once you've got it to a special angle, you could always cheat, and it would be possible for the markers to know. Right, but it's also good just to understand this in terms of understanding what trig is. So the first thing I want you to do is, if I took a circle with a radius, pick any number, but I'm going to pick 2, doesn't make any difference which number we picked. I want you to go write down the circle has a radius which is equal to 2. Excuse the circle, it's not very good. Write down the coordinates of the points at 0, 90, 180, 270. Okay, so go do that. And hopefully that wasn't too testing. Okay, if your radius is 2, then this point will be 2 across, nothing up. This point will be nothing across from the origin and 2 up from the origin. This will be 2 to the left, so it's negative 2 and nothing up. And this will be nothing across and negative 2 down. Right, so now for 0, 90, 180, 270, 360, we know x, y, and r, so I can find any trig ratio. So now I want you to, don't go cheat and use a calculator, there's no point. Okay, evaluate without a calculator, so I want you to use this diagram to answer these plus your trig definitions, which is sine is y over r, etc. Cos is x over r, tan is y over x. And go answer sine 90, evaluate sine 90, cos 180 degrees, tan 270 degrees, and sine of 360 degrees. Using that diagram and your definitions, shade your rear because x-rays tan your exterior. Right, give it a quick go, it should take you a minute. So, sine of 90. Well, sine of 90 is the ratio of the y-coordinate over the radius. So your y-coordinate at 90, if I go through 90, my y-coordinate is 2, my radius is 2. So sine of 90 is equal to 1. Cos of 180 is the ratio of the x-coordinate at 180, which is negative 2. So it'll be negative 2 over the radius, which is 2, which is going to be negative 1. Tan of 70 is the ratio of the y-coordinate over the x-coordinates. And the y-coordinate is negative 2, and the x-coordinate is 0. So tan of 70 is undefined, or it does not exist. Remember, on your tan graph, at 270 degrees, okay, there's an asymptote. At tan of 270 degrees, there's an asymptote, so because it's undefined for that reason at 270. And sine of 360, it's the ratio of the y-coordinate of the radius. At 360, your y-coordinate is 0. Your radius is 2, okay, and 0 over 2 is 0. Okay, so that is finding angles on the axes. Good day. Good day, madam. Just lost her enthusiasm as the day has progressed. How sad. Okay. It's just not made of strong enough stuff.
The maths is killing me.
Musicians.
Killing me.
Useless bunch. Right. Looking at 30, 45, and 60. Okay, so the way I've just drawn quadrant 1, there's the x-axis, there's the y-axis of the Cartesian plane. And the way I remember special angles is I draw in my 30, 45, 60 degrees. And then basically what's happening to the x-coordinates as you're moving across is they're getting smaller. And the way I remember it, it's of course nonsense, they get smaller by 1 root each time. So here it would be root 4, which is just obviously 2. Okay, then it gets 1 less, which is going to be root 3, 1 less root, which is root 2. Of course, that difference and that difference aren't the same. And that'll be root 1, which is just 1. And at 90 degrees, the x-coordinate is 0. And likewise, what's happening to the y-coordinates at these crosses? Okay, at the point of contact with the circumference, okay, they're getting 1 bigger. So here the y-coordinate is 0. It's bigger by 1 root, so this will be root 1, which is 1. This will be root 2, and that'll be root 3, and that'll be 0, 2, or 0 square root of 4. So 0, root 1, root 2, root 3, root 4, with the x-coordinates are getting smaller, root 4, root 3, root 2, root 1, 0. It's just a way of remembering it. It's a bit of nonsense in a way. So now using your definitions, that sine is equal to y over r, cos is equal to x over r, and tan is equal to y over the y-coordinates over the x-coordinates. At that point, go work out for me without a calculator and using that diagram, sine 30, cos 45, tan 60. Give it a go. So, sine 30, we're working at 30 degrees. I'm at this point over here. At 30 degrees, your y-coordinate is 1. Your radius everywhere throughout the sum is 2. So it's 1 over 2 is sine 30. Cos 45, well, cos is the ratio of the x-coordinate over the radius. So I'm at 45, which is over here. The x-coordinate is root 2. The radius is 2, so it's root 2 over 2. You can check all of these on your calculator. And tan of 60 is going to be the y-coordinate at 60 degrees. So I'm at this point over here. The y-coordinate over the x-coordinate is going to be root 3 over 1. In other words, just root 3. Okay, so I always use that diagram. So I'm going to try to solve things from special angles. Right, more likely, I'm a bit nervous because man's picking up some stuff off the floor. I'm in trouble. Okay, more likely than just getting the straightforward special angles is you're going to be asked to evaluate the trig functions of angles which you have to first reduce to get to special angles. So if you're asked in a normal exam to evaluate this without a calculator, you at least have to show the step of getting it to the special angle. That's probably the biggest skill involved here, because after that you could, once you get to a special angle, as I say, in a normal maths exam, you could cheat. So 210. So what I do, I'll say, okay, 210 is in quadrant 3. Okay, so in quadrant 3 it's going to be 180 plus something. Okay, so it's going to be 180 plus 30. Then I say, right, sine of 180 plus an angle. I mean, in quadrant 3, what happens to sine in that quadrant? It becomes negative. So you get negative sine 30. And then you go use that diagram. At this stage in a normal math exam, you could shove it into your calculator. No, I didn't know any better. But if you're going to do it properly, okay, or there's no calculator in the room, negative sine of 30 is going to be negative the y-coordinate, which is 1, over the radius, which is 2. Right, try to do those ones if you haven't done it. Cos 315, tan 120, and sine negative 45. So cos 315, I would say 315, I'm in this quadrant over here. So that's going to be 360 minus something. So it's going to be cos of 360 minus 45. And 360 minus, I'm in quadrant 4. What happens to cos in quadrant 4? It stays positive. So it's going to be cos of 45. Then I can go use this diagram and your definitions. Cos of 45 is the x ratio of the x-coordinate over the radius, which is going to be equal to root 2 is the x-coordinate, and the radius is 2. Right, tan 120, give that a go. Well, I would say, right, 120 is where? 120 is in quadrant 2, so I'm going to write it as 180 minus something. So it's going to be tan 180 minus 60, okay, and tan 180 minus 60, tan becomes negative, so it's negative tan 60, and at 60 degrees, I'm over here, the y-coordinate is going to be negative root 3 over the x-coordinate, which is 1, so it's just going to be negative root 3. And then for the last one, sine of negative 45, we'll just make the angle positive. So sine of negative an angle is the same thing as negative sine of the angle, which is going to be equal to negative root 2 over 2. Okay. Greetings. So a kind of typical exam type of question would be something like this. Evaluate without a calculator. Without a calculator, it tells you that you're going to have to be using special angles, so you're going to have to get them to 30, 45, and 60 degrees. So, you do have to show you're working here. If you just write, you could enter that straight into your calculator, and if you did that though, you just get an answer of, you'd get whatever your answer is, you'd get allocated no marks, so, because it did say without a calculator. So the first thing I do in these questions is put these brackets in, otherwise sometimes you start getting confused as to where you're minusing and where you're multiplying, etc. So I always put in those big square brackets. Then, sine of a negative angle is negative sine of that angle. You can learn to skip on some steps. Okay, minus, well, 120 is in quadrant 2, so I'm going to write it as 180 minus, so it's going to become tan of 180 minus 60 degrees. Okay, and cos 330 is in quadrant 4, so I'm going to write it as cos of 360 minus 30. You don't necessarily have to show this step, okay, but you do have to show that at least the step where you got them to special angles. So then this will become negative sine 180 minus 30 in quadrant 2. Then if I do my reduction, tan of 180 minus, I'm in quadrant 2. What happens to tan? Okay, tan becomes negative in quadrant 2, so it becomes negative tan 60 degrees. Okay. Quadrant 2, negative tan 60 degrees, and then this over here, cos of 360 minus 30, I'm in quadrant 4, cos stays positive, so it's cos of 30 degrees. So normally you'd have a mark allocated there and there, you'd probably get one allocated there, and then I'm going to end up with here, sine 180 minus, it's going to be positive, so it's going to be negative times a positive sine 30. Okay, then I can go start working these out. And quite honestly, if you're in a normal math exam, you shove it into your calculator at this point. Is that not right, Brogan?
Yes.
Okay, but here, okay, if you're thinking of your diagram, at 60 degrees, tan is y over x, y would be equal to root 3. So negative tan 60 would be negative root 3 over 1. Okay, because y coordinate over the x coordinate, if I'm right. Yep, I am, I think. Cos of 30, well, the x coordinate would be root 3, and the radius would be 2. And then sine of 30, the y coordinate would be 1. So the radius would be 2. If I simplify this, I get minus 1 minus, hang on, I wrote the mistake here. Cos of 30 degrees, that's root 3. I do apologize. Hopefully you spotted my deliberate error. Cos of 30, the x coordinate is root 3. So this will be root 3 times root 3 is 3. So it'll be minus 1 over 2 minus 3 over 2, which is minus 4 over 2, which is minus 2. Feeling I've made a careless mistake somewhere. Tan of 60 is going to be y over x, root 3 over 1. Cos of 30 is root 3 over 2. Sine of 30 is root 2.5, so I get negative a half minus 3 over 2, which is minus 0.2, which is minus 2. Okay, I think that's right. If you spot the deliberate error, let me know. So I spotted the deliberate error. Okay, hopefully you picked it up. A negative and a negative makes a positive, so that'll be positive. So it'll be minus 1 over 2 plus 3 over 2, which is 2 over 2, which is 1. Lovely stuff. One more like this. Give this one a go, please, guys. Evaluate without a calculator. So it's telling you special angles that no calculator bits. Tan squared 330 degrees. That's a square. Tan squared 330 degrees minus sine 120 times tan 135. So your first step is going to get everything in terms of your special angles. In other words, in terms of 30, 45, and 60. You're going to use the reduction formula to do that. And in other words, you're using that diagram over and over again. Okay. The first thing I would do in the sum, so give it a go. Okay. First thing I would do though is I would rewrite it always like that. Okay? And then tan 330 is in quadrant 4, so it's going to be tan of 360 minus 30 all squared. I'll also put those brackets in the beginning. Okay, sine 120 is in quadrant 2, so it's going to be minus sine 180 minus 60. And tan 135 is in quadrant 2, so it's going to be tan 180 minus 45. Excuse the mess there. Okay, don't get really marks allocated there, but you will be good for the next line. Tan of 360 minus 30. Okay, well, you're in 360 minus, you're in quadrant 4. Tan is going to become negative, so it's going to be negative tan 30 all squared. Okay, minus sine 180 minus 60, I'm in quadrant 2, sine stays positive, so it's sine of 60, which is a special angle. Tan 180 minus 45 is going to be negative tan of 45. So you'll get a mark allocated there, there, and there. And then you can go cheat and use your calculator, or you can go and use your diagram, this diagram over here. So tan of 30 is going to be y over x, which is going to be negative 1 over root 3 squared, minus sine of 60 is going to be y over r, where 60 degrees your y value is root 3 and your radius is 2, minus tan 45, which is minus root 2 over 2, which is just root, I'll show that if you want to, you could just write it's equal to negative 1. So I end up with 1 over 3 when I square that out, and this will be minus root 3 over 2, because that's just 1, and if we get it all over 6, times that by 2, so it'll be 2 times that by 3. Okay, and that is that, ladies and gents. Right, so another common type of example is this, which is really under reduction formula, not special angles. I forgot to do it, sorry about that. And it's questions of this nature. So given, you're told that sine of 28 degrees is equal to m, evaluate in terms of m, and they give you a whole lot of things over there. Okay, so what the question is really saying to you when they say evaluate in terms of n is simply get everything, express everything as sine 28. Okay, because then it becomes pretty easy with one exception. Okay, and if the angles, okay, so let's just have a look here. Just review. Right, so you've done these before, so just see if you remember how to do these, give it a go. Get everything in terms of m, and then you can come have a squiz at the answers. Right, so sine of a negative angle is going to simply be negative sine of that angle, okay, which is simply going to be equal to negative m. Easy peasy, lemon squeezy. Right, this, well, let's get it to 28. So sine of 208 is going to be sine of 180 degrees plus 28 degrees. I'm in quadrant 3, sine becomes negative, so it's negative sine 28, which again is equal to negative m. Cos 118, well, there are a couple of ways you could do it. You're in quadrant 2, but if I go 180 minus, then 180 minus 28. If I go cos 180 minus 28, it's not going to be equal to that. So there are a couple of ways you could do it, but I'm going to do it like this. So now I'm in quadrant 2, and 180 minus isn't going to work, so then I'm going to try 90 plus, and voila, 118 can be expressed as 90 plus 28. Okay. Now I'm in this quadrant over here. What happens to the original name? To cos in that quadrant, cos becomes negative. And because it's a 90, there's going to be a name change. So it's going to be negative sine 28. It changes to its cofunction, which again is negative m. Right? Please don't always think you're going to get negative a letter as your answer. That's just coincidence. Now the ones you have to look out for, oddly enough, are the ones where the angle in the question, okay, is the same as the angle that's given. Okay, so those two things are the same. So you've got, in other words, the magnitude of that angle is 28, and the magnitude of that angle is 28. Then I'm going to do the questions like this. You're going to have to, can't go use a reduction. So what we do is we say, right, I know that sine 28 degrees is equal to m which means m over 1. So if I'm on the Cartesian plane, and I drew in an angle of 28 degrees, then I know the definition of sine is the ratio of the y-coordinate over the radius, right? So I know that for 28 degrees, if the radius is equal to 1, then the y-coordinate will be m. So what I've got to go find is the x-coordinate, because cos is the x ratio of the x-coordinate over the radius. So I need to go find this x-coordinate over here. And what links up the x, y, and the radius? Well, it's your equation for your circle. X squared plus y squared is equal to r squared. So you're going to have x squared is equal to r squared, and r is 1. So it's 1 squared minus y squared. So 1 squared minus m squared. So x squared is equal to 1 minus m squared. So I hope you can see this. So x is equal to the square root of 1 minus m squared. Strictly speaking, you should put plus or minus. Well, you should put. But if you look at the diagram, I don't have to worry about the minus because you can see that the x-coordinate is positive over there. So I'm just going to leave it as root 1 minus x is square root of 1 minus m squared. So there's my x-coordinate. Okay, so to work out cos 28, it's going to be the x-coordinate, which is 1 minus m squared, over the radius, which is simply equal to 1. So your answer is just going to be the square root of 1 minus m squared. So use reduction formula, but if the angles are the same, okay, given angle and the requested angle are the same, trig ratio are the same, then you're going to have to use this technique of x squared plus y squared is r squared in order to find the missing variable and go from there. Right, the next type of grade 11 revision we're going to look at is trig identities. And trig identities are questions of the type where you've got to prove the left-hand side is equal to the right-hand side. They're quite a lot of fun. I don't know. Anyway, I better not say it. I don't think they're particularly useful. But anyway, got to do them. And as I say, they are entertaining. And so some key ideas are that sine squared theta plus cos squared theta is equal to 1. That's on your information sheet. Look out for that. It can make your life easier. Not always, but okay, if they're questions where they're just tan, then don't go change tan, generally speaking. But very often what you're going to have to do is change tan into sine theta over cos theta. So if you see sine and cos and there's a tan, generally you're going to do that with tan. Don't forget, from this square identity, it may help you if you manipulate that equation. Sine squared theta, being a dumbass, it's easier to write it like this. Okay, 1 minus cos squared theta is equal to sine squared theta, and 1 minus sine squared theta is equal to cos squared theta. That can help you. Sometimes, nearly always, you want to use it in that direction, not in the opposite direction. That makes your life more complicated. Don't forget some basic algebraic skills. Okay, so look to factorize. Sometimes that can help you. So if you go factorize, you'll just do it as a little exercise. Go factorize sine squared theta minus 1, and go factorize 2 cos squared theta minus 3 cos theta minus 2. Give those a go. So sine squared theta minus 1, we'll look for a pattern to get x squared minus 1, and to factorize to x minus 1, x plus 1. So this over here can factorize to sine theta minus 1, sine theta plus 1. In a case like this, well, cos theta is just a value. So you could let, for instance, cos theta be k, and you get 2k squared minus 3k minus 2, which can be factorized to 2k k minus 2 plus 1, 2k squared minus 3k minus 2. So using that logic, and it helps some people to go to the side of their page and do that, we can factorize this to 2 cos theta plus 1, 2 cos theta minus 2. I'm just following that pattern over there, but you don't have to show this. Okay, you can go straight to there. The other thing, don't forget your basic simplifying. Okay, in other words, just like if there's a fraction and you're adding them, okay, go add by getting your LCD. Okay, the basic rules of algebra, still apply them. And just one last thing, in a very dire emergency, when nothing else is working, don't rush to this. You can rewrite 1 as sine squared theta plus cos squared theta. generally it's in a question where we get sine theta, cos theta. In that situation, like 1 plus, then you could go write that and then factorize. Okay, but generally, okay, just don't rush to do that. So likewise, 2 would be equal to 2 sine squared theta plus cos squared theta. These videos are taking it out of me. Okay, let's just do practice a couple of identities. Right, try that one. It's pretty short, it's pretty easy. Okay, give it a go. Prove that sine theta plus cos theta all squared is equal to 1 plus 2 sine theta cos theta. So if I work with the left-hand side, well, I'm simply going to use this logic that a plus b squared is a squared plus 2ab plus b squared, which hopefully you know. So this is going to become sine squared theta plus times them together times by 2 plus 2 sine theta cos theta plus cos squared theta, and then this should sing out to you like a banshee. Sine squared theta plus cos squared theta is equal to 1. So it's going to be equal to 1 plus 2 sine theta cos theta. And we are done. Okay, so we can finish it off and say which is equal to the right hand side. Lovely stuff. Right, give this one a go. It says prove sine squared theta plus sine squared theta tan squared theta is equal to tan squared theta. Okay, right, so try that. The AP girls, you'll know that there's a much easier way to do this. If you took out sine squared theta, and then you'd be left with 1 plus tan squared theta, which would be sec squared theta, and then you're just about done. But alas, we don't do that in core. So our only real option at this stage is to rewrite tan squared theta on the left-hand side as sine squared theta over cos squared theta. Okay, so we're going to say, hang on, just pause a second. Right, sorry about that. So here, there's numerous ways you can do this, but a lot of you, your first instincts will be, and that's not wrong, to try write tan squared theta as sine squared theta over cos squared theta. Okay, I'm just working with the left-hand side. Okay, if you want, on the right-hand side, you can pick up some marks straight away by going right-hand side is equal to tan squared theta, which is equal to sine squared theta over cos squared theta. That gets you some money in the bank. But over here, as soon as I get fractions, I would do that. So this becomes sine squared theta, you can skip out steps, plus sine to the 4 theta, x squared times x squared is x to the 4. Okay, all over cos squared theta, fractions, let's put that over 1. So now, how do we add fractions? Sin squared naught, we'll get a common denominator of cos squared theta, times the bottom by cos squared theta, must times the top by cos squared theta. Okay, right, and now let's factorize the numerator in 2 terms, and I can take out, if you had x squared y squared plus x to the 4, you could take out x squared, so here I can take out sine squared theta, and I'll be left with cos squared theta to times, what I have to times y to get back to there, to cos squared theta to get back to sine to the 4 theta, plus sine squared theta. Hallelujah, you should be saying now, hallelujah, hallelujah. Why is it hallelujah? Because that is 1. So I'm left with sine squared theta over cos squared theta. Remember, that's just 1, which is equal to, okay, well, let's just write it like that. Praise be, the left-hand side and the right-hand side are, we've shown to be the same. Remember, always split your page up if you're going to be working with both sides. Don't tell us that they're equal in the beginning, because they're not. You're trying to prove that. So you should finish it off and say, dear Mr. Marker, I have shown you, or Ms. Marker, or Mrs., or no identified gender person, that the left-hand side is equal to the right-hand side. Lovely. Right, let's try another one. The question is prove 1 minus cos squared theta over cos squared theta plus 2 cos theta plus 1 is equal to 1 minus cos theta over 1 plus cos theta. Could work with either side. In fact, quite easy to rush 2 times the right-hand side. Okay, we'll just give it a go. Give it a go. Right, so one of the ways we could have done it is times the top and the bottom by 1 plus cos theta, 1 plus cos theta. That would be one way to do it. Okay, I'm not going to, you can get this down, but so you could have done that. Okay, if I worked with the right hand side, and then you'd get 1 minus, if I times that out, you'd be allowed to do that. If you times that out, you'd get 1 minus cos squared theta over 1 plus cos theta is plus 2 cos theta plus cos squared theta, okay, which is equal to the left hand side. Okay, so that's one way you could have done it. Okay, timesing the top by 1 plus cos theta, 1 plus cos theta. Because remember, if you do the same thing to the numerator and the denominator, effectively you do nothing. You're timesing by 1. Okay, so that's one way you could do it. You could work with the right hand side. Okay, but so get that down if you want to get it that way. But probably I would guess that most people would work with the left hand side. Okay, be careful, don't go turn that into sine squared theta, because there's no signs on that side. Okay, so I wouldn't bother with that. But you could factorize that. So go try factorize that, and go try factorize that. Okay, and see what happens. Well, if you had 1 minus x squared, it would factorize to 1 minus x, 1 plus x. And if you had x squared plus 2x plus 1, which is the same pattern as that, you'd factorize it to x plus 1, x plus 1. So in other words, this could factorize to cos theta plus 1, cos theta plus 1, or else you could just write cos theta plus 1 all squared. And cos theta plus 1 and 1 plus cos theta are the same thing. So you're left with 1 minus cos theta over 1 plus cos theta, which is equal to your right hand side. So there is always more than one way to club a budgie to death when it comes to identities. Right, last one for today, for this lesson. Okay, prove 1 over 1 minus sine x minus 1 over 1 plus sine x is equal to 2 tan x over cos x. Okay, I'm probably going to work with both sides. So remember, that's a question, but when you work with it, don't tell us that they're equal. Split it up into the left-hand side and the right-hand side. Okay, and the right-hand side, well, I could go 2 tan x is the same thing as 2 for 1 times sine x over cos x. And instead of having that, I'm going to write divided by cos x over 1. Okay, that's the bottom bit over there. I've written a divide sign instead of that line. And then I'm going to end up with 2 sine x over cos x times by tip and times 1 over cos x, times fractions, times the top times the bottom. So I get 2 sine x over cos squared x. So now the question becomes, show that this over here is equal to 2 sine x over cos squared x. Right, so go work with that side. You're adding fractions. So when you add fractions, what do you get? You get a common denominator. If there's 1 over 1 minus a minus 1 over 1 plus a, you get a common denominator. So let's try that. Your common denominator is going to be 1 minus sine x, 1 plus sine x. Okay? And what did I times the bottom by to get to there? I times by 1 plus sine x. So I must times the numerator by that. So I get 1 plus sine x over there. Then minus, be careful, you're minusing the whole thing. Eh? Here I times by 1 minus sine x, the denominator, so I must times the numerator also by 1 minus sine x. Okay? And if I simplify that, I'm going to get, well, I would times out the bottom because I'm trying to keep looking, glancing between the two sides. Here I've got 1 minus sine x, 1 plus sine x. Here I've got cos squared x. 1 minus sine x times 1 plus sine x you should recognize is 1 minus sine squared x. Hallelujah. And okay, we should then be ecstatic because 1 minus sine squared x is the same thing as cos squared x. So I've got my numerator to be, the denominator to be the same. And if I just go neaten up, okay, the numerator, 1 minus 1 is 0. Okay, I'm going to end up with 1 if you want to distribute the negative first. 1 plus sine x minus 1 plus sine x. We get 2 sine x over cos squared x, and voila! Blah, blah, blah. The left-hand side is equal to the right-hand side. We are done. Right, so for the matrix, what I do want you to do is Mindball Maths, grade 12, book, exercise 4.1, page 130. You should have done A, B, and C already. Okay, go do D, E, and F now. And remember that you shall never walk alone. Au revoir.